Solving quadratic equations with factoring. In this video, we'll use the zero product property to solve quadratic equations, and we'll check some solutions in the original equation. If you multiply a number times 0, the product is 0. The converse is also true. If the product is 0, one of the two numbers must be 0. Here's an equation with two factors, and the product is equal to 0. So either x minus 8 equals 0 or 2x plus 3 equals 0. Each of those is a linear equation that we know how to solve. If x minus 8 equals 0, I can just add 8 to each side, and I find that x equals 8. If 2x plus 3 equals 0, I can subtract 3 from each side, and 2x equals negative 3, and then divide by 2, and x equals negative 3 halves. So I found two solutions. Now x is not both numbers at the same time. For example, if x is 8, then I have 8 minus 8 and 2 times 8 plus 3. So the factor 2x plus 3 is 16 plus 3 or 19, but it's multiplied by 8 minus 8, which is 0. If x is negative 3 halves, it's negative 3 halves in both factors. But the first factor is negative 3 halves minus 8. That's negative 19 halves. But the second factor is 2 times negative 3 over 2, which gives me negative 3 plus 3. The second factor is 0, and negative 19 halves times 0 equals 0. So this is a logical OR. X is one number at a time, and it's either 8 or negative 3 halves. They're two separate solutions. Here's a quadratic equation. It has an x squared. X squared plus 8x equals negative 15. I want to try to solve it by factoring. So the first thing I need to do is get 0 on one side. To do that, I'm going to add 15 to each side. That gives me x squared plus 8x plus 15 equals 0. The second step is to factor that. So I look at 15. 3 times 5 is 15, and 3 plus 5 is 8. So I have x plus 3 times x plus 5, and that product equals 0. Well, by this zero product property, then either x plus 3 equals 0 or x plus 5 equals 0. If x plus 3 equals 0 and I subtract 3 from each side, x is negative 3. If x plus 5 equals 0 and I subtract 5 from each side, x is negative 5. These are the two solutions of the original quadratic. Let's try them and see how they work. If I try the first solution, negative 3 in the equation, I have negative 3 squared plus 8 times negative 3. That gives me 9 minus 24. And the question is that equal to negative 15? Well, in fact, it is. Hooray! It works. The second solution is negative 5, so let's put that in the original equation. Negative 5 squared is 25, plus 8 times negative 5 is 25 minus 40. Is that equal to negative 15? Well, yes. It actually is. So these solutions each work back in the original equation. The solution set for this equation, written in set brackets, is negative 3 and negative 5. Here's a quadratic equation. 6n squared minus 18n minus 18 equals 6. Now, because you have a full quadratic on the left, you might be tempted to start factoring too soon. But remember, step 1 is to get 0 on one side. To do that, I'm going to subtract 6 from each side. Negative 18 minus 6 is negative 24, and 6 minus 6 is 0. Now I'd like to start factoring, but before I do, I notice that 6, negative 18, and negative 24 are all divisible by 6. Now, if this were an expression, we would factor that 6 out. But since it's an equation, we can just divide by 6 on both sides. 6n squared divided by 6 is n squared. Negative 18n divided by 6 is negative 3n, and negative 24 divided by 6 is negative 4. 0 divided by 6 is still 0. Remember, 0 is okay in the numerator, it's just not good in the denominator. If we had missed that step, it wouldn't mess up the answer, it would just make factoring more difficult. So step 2 is to factor. The leading coefficient is 1, so each factor begins with n. And negative 4 is equal to negative 4 times positive 1, which gives me the negative 3 in the middle. Negative 4 plus 1 is negative 3. So now I have two factors equal to 0. So n minus 4 equals 0. If I add 4 to each side, gives me n equal 4. If n plus 1 equals 0, and I subtract 1 from each side, n equals negative 1. I found two solutions. I want to show you one more because this kind sometimes drives students a little crazy. I have 7x squared minus 6x plus 3 equals 3. So I start by I subtract 3 from each side, and now I have 7x squared minus 6x equals 0. There's no constant term. Instead, what we have is a greatest common factor, x. So I factor out x, and I end up with 7x minus 6. Equals 0. Now I have my two factors. X is a factor. So either x equals 0 or 7x minus 6 equals 0. Well, x equals 0 is already solved, so I'm good there. I just have to solve 7x minus 6 equals 0. I add 6 to each side. 7x equals 6, and divide by 7. And x equals 6 over 7. So my two solutions are 0 and 6/7. It's okay to have 0 for a solution.